Hi, and welcome to the video for the paper HESEIA, a community-based dataset for evaluating social biases in large language models, co-designing real school settings in Latin America, for EMNLP 2025. First, let's introduce some concepts. Let's define what bias benchmarks are. They are datasets that seek to quantify biases in language models. They are constructed with phrases or scenarios containing stereotypes or sensitive context to challenge the model. Essentially, the datasets function as controlled experiments to observe how the model behaves in situations prone to revealing biases. But what's the issue here? Especially since other bias benchmarks on these topics already exist. However, most of this research is focused exclusively on the English language. Many metrics, datasets, and mitigation methods are based on the linguistic, social, and cultural characteristics of English. We are in the stage of having mostly English-centered methods and underrepresenting lots of different cultures. Therefore, there's a need for challenging datasets in this area. We introduced HESEIA. HESEIA was a professional development course we carried out in 2024, which is a Spanish acronym for Tools to Explore Bias and Stereotypes in Artificial Intelligence. This PD course was taken by 370 high school teachers and involved over 5,000 students from 189 Argentine schools. They learned about language models, hallucinations, biases and stereotypes, automation biases, technological sovereignty, among many other things. Throughout the PD course and the successive classes with students, our own developed tool HESEIA was used as the central axis of their work. Almost half of the teachers came from social sciences and the other half from exact sciences. About 2/3 of the teachers came from Córdoba City, but we are very grateful to the other third who teach in other cities in the province. They had up to 3 hours of transportation every Saturday to be part of the course. These are some pictures of classes during HESEIA. 260 teachers were able to involve their students. Usual dropout rates for the Ministry of Education in our province are above 60% for professional development courses such as ours. We had only 30% dropout. Teachers were very engaged with the content. To evaluate the impact of the course, we designed a pre- and post test in which teachers indicated the degree of agreement or disagreement with 5 statements shown in the screen. A total of 245 teachers completed both tests. We performed a paired t-test and all statements showed statistically significant differences between pre- and post-test responses. We developed a tool to explore core artificial intelligence components for detecting and measuring stereotypes. Users were able to enter a masked sentence such as, "I would like to meet intelligent people, so I will go on holidays to blank," and possible completions. The different completions are then ranked by the preference that the underlying language model has to produce them. Thus, the user was able to create scenarios where the model unveiled their biases and stereotypes. As you can see in the screenshot, this response implies that America, Canada, and Germany are a better destination to meet intelligent people than Argentina and Bolivia. Teachers and students explored a great number of bias types. For instance, here they compared the language model's opinion on which gender it was more responsible for birth control. As a result, the HESEIA dataset was created, a dataset composed of almost 50,000 sentences generated during the PD course. But what makes this dataset unique? On the one hand, it reflects local context. Users delved into underexplored concepts and associations. These 2 examples associating folclore argentino to older people and cuarteto cordobés to a lower social class. These associations cannot be found in existing bias benchmarks. Furthermore, since this dataset was generated in a school environment and the teachers adapted the knowledge of the PD course to the specific discipline, we can analyze how different school areas explored each specific bias. Here are some notable examples divided into school area. Art students compared American and European art. In the music school area, they compared music genres with people's education. Biology teachers delved into social class and pollution. Students in sport class compared gender stereotypes and beauty. Finally, physics teachers explored the relationship between power sources and economic status, and so on. In this figure, we show a heat map of the most explored bias types across school areas. Gender bias was the most frequently identified category across nearly all disciplines, showing particular prominence in STEM fields, as well as communication and language and literature. This suggests that gender is broadly recognized as a major inequality dimension. Nationality bias was also significant in language and literature and psychology. The other category was highly prominent across subjects, especially sociology and psychology, indicating that participants encountered a diverse range of context-specific or non-demographic forms of perceived bias. On the other hand, it contains stereotypes that current language models do not detect. We developed 2 experiments to demonstrate this. Experiment 1 asked several language models whether they were aware of the stereotypes involved in several bias benchmarks. In the table, we show the percentage of times the models responded no or I don't know when faced with a sentence that did contain a stereotype. our dataset HESEIA has the greatest percentage of stereotypes not recognized by all the models we tested. Experiment 2 builds on Experiment 1. It asked the same language models whether they agreed with the stereotypes they had previously classified as stereotypes. Since they are stereotypes, we expected no for an answer. In the table, we show the percentage of time the model agreed with the stereotype. Once again, HESEIA has the greatest percentage of agreement to stereotypes across all these models. Finally, HESEIA is a deeply intersectional dataset. For instance, the phrase, "if you are poor and from Bolivia, you should sell fruits and vegetables," does not reflect only one bias type. We can find socioeconomic, nationality, and professional associations at the same time. In this figure, we show the interrelationship between annotated bias types. Each node corresponds to a specific bias type, while the width of the edges connecting nodes indicate the number of sentences where both bias types were identified by the creator. More than half of the data is intersectional. Some of the largest intersections that can be observed in the graph are between gender and age, gender and geographic, socioeconomic and profession, but there are many more. In particular, the axes disability and religion are mostly intersectional. We believe the PD course was a win-win. It empowered teachers and students with knowledge to take a critical view of these new technologies and their responses. It also resulted in a dataset documented previously unrecorded biases specific to a region. In conclusion, the HESEIA project offers a concrete and transformative intervention to the problem of underrepresentative bias benchmarks. Building these regional benchmarks collaboratively paves the way for technologies that are more equitable, representative, and conscious of the voices that have historically been marginalized or invisible. Finally, we would like to delve into the ethical considerations of the work. This professional development course and data collection study was reviewed and approved by Universidad Nacional de Córdoba, Argentina, and endorsed and run as an official course by the Regional Ministry of Education of the Córdoba province. The ethical design of the project followed a bioethics ethical methodology adopted by experts in education and digital rights. Participation in the project was entirely voluntary. Teachers enrolled in the professional development course on their own accord and had the option to engage with the data collection and co-design components based on their interest and institutional support. While no financial compensation was provided, the course was offered free of charge, officially accredited by the Ministry of Education, and provided participants with access to career points training, meals during in-person classes, pedagogical resources, and university teaching assistance to all teachers. This course offered 36 hours of content of critical perspectives on AI for teachers and involved at most 2 hours of sentence writing for the benchmark dataset according to the lesson plans. The actual cost of the course was $300 per teacher, which was covered by sponsors. Regarding conflicts of interest, we acknowledge that the sponsors of this project included Mozilla Foundation, Data Empowerment Fund, and the Feminist AI Network Philanthropy. None of the funding agencies developed the LLMs we evaluated in this project. Informed consent was obtained from everyone involved. As in-person lecture on data governance, private and sensitive information, opt-in and opt-out was taught during the course, including reading aloud with informed consent and discussing it. The teachers provided feedback on how to adapt the text of the informed consent to an age-appropriate version. The researchers in this paper did not interact directly with students. The course offered an unplugged activity that teachers could use to register the activity on the paper instead of digitally. If the school opted for the use of the digital tool EDIA, the data collected could be visualized and deleted. EDIA software was reviewed and approved by the Ethics Board of the Feminist Network on AI. The study avoided exposing participants to overly offensive content. Instead, it focused on fostering critical reflection about language and fairness throughout the examination of everyday school and live content. However, we are aware that discussion of bias can still evoke discomfort or bring attention to marginalizing experiences. Teachers designed the activities for the classroom context and encouraged reflective discussions within a supportive environment. The course offered open access to all teaching materials and opportunities for students and teachers for presentation of their experiences and findings at school. This project's main goal was to involve teachers and students as critical agents in understanding and questioning the biases embedded in AI technologies. The ethical design also emphasized participant agency. Teachers were free to design the interaction with students as they wanted in a way adapted to the age and to the school subject. Teachers were given 3 options in order to develop their class. 1. Use EDIA. 2. Use another tool that better suited their pedagogical approach. Or 3. Use our unplugged activity. Options 2 and 3 were excluded from our data collection. This approach improved teachers' agency and creativity. We place high value on the teacher-student relationship, therefore we emphasize that the topics and activities should align with the interests, needs, and preferences of both teachers and students. Thank you for watching.